Imagine a grand cosmic performance orchestrated by an infinite number of stars, planets, and moons, all playing flawlessly in time. However, one section of this celestial harmony has puzzled astronomers for centuries: exoplanets. Exoplanets are natural, non-solar planets that exist outside our solar system, deep within the vastness of the Milky Way galaxy. You might be surprised to learn that among the numerous cosmic entities, there are exoplanets that 35 seconds. They might actually be Earth's twin. As we explore the captivating world of Proxima b, which is only 4.2 light-years from our planet, the James Webb Space Telescope is revolutionizing our ability to explore and understand these celestial enigmas. Imagine, for a moment, that your mind wanders through the enormous astronomical domain of our galaxy, the Milky Way. The Milky Way contains over a quadrillion exoplanets, a 1 followed by 15 zeros. 1 minute and 8 seconds. This staggering number is like grains of sand that would not only fill the Grand Canyon but also provide enough material to build a brand new geological wonder, Grand Canyon 2.0. Surprisingly, about 20% of these celestial bodies have been identified as Earth-like in terms of their geological and atmospheric characteristics. This means there is a 1 in 5 chance of finding a planet similar to our own. But the story doesn't end there. If we were to contemplate the possibility of discovering another space-bound body capable of supporting life, the cosmos offers countless opportunities. Now that we have opened the canvas of the cosmic expanse, it is time to introduce the master artist who is ready to paint its fine details, the James Webb Space Telescope. 2 minutes and 14 seconds. This celestial Sherlock Holmes, equipped with its telescopic lens in place of a magnifying glass, surpasses even the most sophisticated optics. This is not just any lens. The 6.5-meter primary mirror is 2.7 times larger than Hubble's. Imagine the precision it provides, allowing it to detect even the faintest star flicker billions of light-years away and analyze the planets in orbit around them. The James Webb Space Telescope is revolutionary not only because of its incredible observational capacity but also because of its cutting-edge technologies, like infrared sensors and spectrographs. These tools can analyze and filter the various light signatures emitted or reflected by celestial bodies, revealing their atmospheric makeup, density, mass, and even composition. Acting like a cosmic detective, the James Webb Space Telescope elevates itself from a mere observer to an analytical genius, surpassing Hubble and making a monumental leap forward. If Hubble's discoveries surprised you, prepare yourself for a variety of celestial revelations. 3 minutes and 21 seconds. While we broaden our view of the vast cosmos, let's focus on a particular star in this celestial performance, Proxima b. Since its discovery in 2016, this mysterious planet has intrigued scientists, appearing like a Shakespearean character, full of complexity and contradictions, captivating astronomers and biologists alike. Why all the excitement? For one, Proxima b is nearly part of our cosmic neighborhood, located just 4.2 light-years from Earth. 3 minutes and 55 seconds. To help put this into perspective, if you could exceed the speed of light, you would reach it in just over 4 years, roughly the same amount of time it takes for a presidential term to pass or for a favorite television show to lose its popularity. But why does its proximity matter so much in a universe that spans over 93 billion light-years? Finding a planet so close and promising for scientific research is like finding a diamond in a pile of stones as big as Mount Everest. This planet may hold the keys to Earth, but it may also be an Earth 2.0 because it lies in what astronomers refer to as the habitable zone of its parent star. 4 minutes and 27 seconds. Proxima b enjoys conditions that are neither too hot nor too cold, making it just the right environment for liquid water to exist. Imagine waterfalls, winding rivers, vast lakes, and perhaps oceans as profound and mysterious as the Mariana Trench. However, before you begin planning your vacation to Proxima b, it is important to note that 5 minutes. A single day on this captivating exoplanet lasts a mind-boggling 11 Earth days. Envision sunrises that not only mark the start of a new day but gradually unfold, resisting the transition to midday. Sunsets stretch on, creating long golden hours that photographers dream of. While it might sound ideal, these long days would also have significant consequences for its climate and habitability. How would humans adapt to such prolonged cycles of light and darkness? Would we need to eat more often, perhaps 3 or 4 times? 5 minutes and 34 seconds. In a single day, would our sleep patterns remain the same as they are on Earth? life, as we know it, would feel both eerily familiar and bizarrely different. One might wonder, how can we gather accurate, reliable data about a world we've never visited? The James Webb Space Telescope uses its full array of capabilities, functioning like a cosmic Swiss Army knife. More than just a telescope, it's a multifaceted research laboratory in the vastness of space. 6 minutes and 9 seconds. Thanks to its cutting-edge technology, astronomers can not only observe these distant planets but also examine them with a variety of analytical tools, such as advanced spectrographs. The Webb telescope can analyze the light emitted and reflected by these far-off planets. Each element or compound in a planet's atmosphere absorbs or emits light at a unique wavelength. By analyzing these wavelengths, scientists can remotely biopsy these planets, assessing atmospheric pressure, density, and even detecting essential compounds for life, such as water and organic carbon molecules. 6 minutes and 44 seconds. This space forensics approach examines the atoms and molecules that make up distant worlds rather than passively waiting for clues. The Webb telescope is not just a passive observer in the sky, it is also a highly specialized lab analyst and cosmic detective all rolled into one. Then, something extraordinary happened. 7 minutes and 17 seconds. Researchers using the James Webb Space Telescope discovered an electromagnetic emission emanating from Proxima b, so complex and structured that it could indicate the existence of an advanced civilization. For a brief moment, humanity held its breath. 7 minutes and 49 seconds. We took a collective breath at the apex of a revelation that could alter everything we know about our place in the universe. Could this signal be irrefutable evidence that we are not alone in the cosmos? However, as soon as it appeared, the signal vanished, leaving only silence and an avalanche of unanswered questions. 8 minutes and 23 seconds. Could it have been a fleeting cosmic phenomenon? A strange alignment of natural forces? Or perhaps a deliberate code, a message from an unknown intelligence? The mystery deepened. As the world's greatest minds scrambled to make sense of the anomaly, a profound sense of urgency took hold. Was this a one-time event, or had humanity just intercepted the first whisper of an interstellar conversation? Harvard researchers, driven by the mystery, decided to take a radical step. They weren't content with simply analyzing signals, they wanted proof. Using the James Webb Space Telescope like a cosmic night vision tool, they turned their attention to an unconventional search, looking for artificial light sources on Proxima b. 9 minutes and 20 seconds. The logic was simple. If intelligent life existed on Proxima b, then perhaps, like us, they had cities, vast, glowing networks of civilization radiating light into the night. For weeks, the telescope scanned the planet's dark side. The researchers combed through terabytes of data, hunting for the telltale glow of artificial illumination. And then, a flicker. A pulse of light. 9 minutes and 59 seconds. At first, the data was inconclusive. Could it have been a reflection from Proxima Centauri, the planet's parent star? Or was this something more deliberate, something that hinted at intelligence? As the researchers refined their models, the evidence became more compelling. The signal's pattern didn't match any known natural phenomenon. It wasn't a transient flare or a wayward reflection, it was structured. The pattern repeated in intervals, like a beacon in the dark. Humanity stood at the precipice of revelation. 10 minutes and 32 seconds. If this was truly an artificial signal, what did it mean? Was someone, or something, trying to get our attention? The implications were staggering. A civilization capable of producing artificial light across interstellar distances meant that we were no longer just looking for life, we were looking at intelligence. It raised a haunting question. If they know we are watching, do they want us to see them? 11 minutes and 4 seconds. The world braced for an answer. Governments, space agencies, and research institutions convened in emergency meetings. Should we respond? If so, how? The risk was unfathomable. Were we making first contact with a peaceful civilization, or were we staring into the unknown with blind optimism? A decision had to be made. The James Webb Space Telescope continued to watch, capturing more data than ever before. Scientists worked around the clock, dissecting every flicker, every anomaly, every possibility. And then, a second pulse. Brighter, closer, deliberate. It was undeniable now. We were no longer alone. 11 minutes and 36 seconds. As the world struggled to comprehend this revelation, another chilling realization set in. If they could see us, if they could send signals across space. Had they been watching us all along? The second pulse sent shockwaves through the scientific community. Unlike the first, this one did not vanish without a trace. It persisted, steady and unwavering, as if waiting for a reply. Debates erupted across the world. Some scientists urged caution. What if this was an observation, not an invitation? Others argued that silence was no longer an option. If they had been watching us, they already knew we existed. But how do you respond to a message from the stars? 12 minutes and 40 seconds. The answer came from an unlikely source, an astrophysics graduate student at MIT named Elena Vasquez. She noticed something strange about the pulse's frequency. It wasn't just a random light signal. When broken down into its component wavelengths, it resembled something eerily familiar. A prime number sequence. 2, 3, 5, 7, 11, 13, 17. Mathematics, the one universal language. This was no accident. This was intelligence. 13 minutes and 13 seconds. Elena's discovery changed everything. The signal was a message, and more importantly, it was structured in a way that suggested they knew we would recognize it. The question remained, what did they want? NASA and the European Space Agency worked frantically, crafting a response. The challenge was immense. A simple radio transmission would take 4.2 years to reach Proxima b. If they replied, another 4.2 years would pass before we received their answer. An 8-year conversation for a single exchange. But there was another problem. 14 minutes and 14 seconds. Someone else had already sent a response. 14 minutes and 28 seconds. It wasn't NASA. It wasn't the European Space Agency. It wasn't any official government entity. It was an independent, rogue transmission. Unidentified. Untraceable. The message was brief, encrypted, and sent directly toward Proxima b. By the time it was detected, it was already on its way, traveling at the speed of light. The content of the message? Unknown. 15 minutes. Panic spread through the scientific community. Who had sent it? What did it say? Had we just declared peace, or war? And then, the pulse changed. It no longer flickered in prime numbers. It was no longer a simple beacon. It was responding. But this time, it wasn't just light. This time, there was sound. A deep, resonating frequency. Unnatural. Measured. Intelligent. And then, a single word. Clear. Undeniable. Spoken in a voice that was not human. Hello. 15 minutes and 49 seconds. The world stopped. The signal had changed forever. It was no longer just mathematics, it was language. But whose? The voice carried no accent, no familiar inflection. It was both alien and eerily understandable. And then, before scientists could analyze its meaning, the signal stopped. Silence. But this time, it didn't feel like an ending. It felt like the beginning.